Have you ever looked at the periodic table and thought, why does it have to be in that order? Wouldn't putting it in alphabetical order or something make it easier to remember? Well, it all starts with a question that philosophers and scientists have been trying to answer for thousands of years. What is our world made of? The ancient Greeks believed that everything was made from four basic elements: earth, fire, water, and air. In the 4th century BC, two Greek philosophers came up with the idea that instead of everything breaking down into smaller pieces infinitely, there was a set building block for everything that humans couldn't see and that could not be broken down. They called these tiny little blocks atoms. Fast forwarding about 20 millennia, alchemists began trying to turn common metals into pure gold. This didn't work, and a lot of them turned out to be frauds. But it led to the discovery of about 47 metals at the beginning of the 19th century. You may be asking, Bryce, why are you going over the history of chemistry and not why the periodic table is organized the way it is? But I'm getting there. When chemists were discovering these elements, they noticed that certain elements shared the same properties. In 1869, Dmitry Mendeleev, a Russian chemist, realized these similarities and published an early version of the periodic table, organized by atomic mass. Mendeleev, noticing a break in the pattern, had added 2 spots for elements that would not be discovered until 1875 and 1886. Now onto the periodic table. Starting on the far right, excluding hydrogen, we have our alkali metals. These metals have only one valence electron, or electron that's on their outer shell. They are very reactive, easily ionized, and have low melting points. Next we have our alkali earth metals. They have 2 valence electrons and are shiny and tarnish easily in air. They are less reactive than alkali metals, but are still some of the more reactive elements on the periodic table. Following these, we have the transition metals. Making up a large amount of the periodic table, these elements are good conductors, having high melting points and can easily be bent into a shape. Next, we have the post-transition metals. These metals have low melting points and are very soft and brittle. After those, we have my personal favorite, the metalloids. These are elements with both metal and non-metal properties. Think of these as the mutation elements of the periodic table. They're not actually mutations, that's just my analogy. And now we've reached the nonmetals. The reactive nonmetals are poor conductors of electricity. Hydrogen is a part of this group, but is put with the alkali metals because it has only one valence electron. The final group we're going to touch on are the noble gases. They have a full outer shell, causing them to have the lowest reactivity on the periodic table. They are unlikely to create bonds with other elements because of how stable they are. But wait, they aren't just organized left to right, but also up and down in what we call periods. The row or period an element is in shows you how many shells that element has. Hydrogen and helium, for example, are in their own row because they have only one shell. We can also organize them into blocks, the order going S, P, D, and F. We use these groupings to write out the electron configuration of any element. And now you know why the elements are in the order they are in on the periodic table. And next time you run into something having to do with the periodic table, you'll be able to figure out what the properties of the elements are using their elemental neighbors.